All right, so today is March 24th, and today we are going to be continuing on in our series here of learning programming. And this is going to be the second day here of us moving faster. So yesterday we had started downloading things on my friend's computer to get the development environment set up. And today we're going to keep doing that sort of setup procedure working with Python and Visual Studio Code. So here's the outline of things that we are going to focus on today. We're going to, first off, we're going to go over, we spent the last few minutes yesterday trying to figure out this reason why I wasn't able to send key presses over the Chrome remote desktop application that we're using here. So we did end up figuring that out. It was actually on my end. I'll go over that. We'll talk about Python virtual environments, which we kind of brought up some yesterday, but we'll actually experiment with them a little bit and talk more about them today. We'll talk about setting up a launch configuration in VSCode, what exactly that means and how that controls how you run your applications. We'll talk about Python packages, so library files that we can use in our code applications, the Python package index, so finding Python packages that you can use, and then pip, which is the Python package manager here. And so just how we had Chocolatey as a package manager for Windows, pip is a package manager for Python. Then we'll go over package dependencies at the project level. So that's managing groups of packages, how you track them, how you stabilize. So you pick a set version and you don't let the version go above that so that your code doesn't break if things change in the version. And then we'll talk about the requirements.txt file, which is conventionally how Python applications store their lists of packages. And finally, I will work on installing Git at the end of today for you. So Git's a version control software. We'll also install SourceTree, and we'll look at GitHub, the website again here. Probably won't do a great deal with it today, just because it would get very late probably, but we'll at least get it set up so that we can go over it the next time we meet. So that's our plan for today. So first off, it took me some troubleshooting at the end of yesterday after we stopped recording, but there was a plugin I use for Google Chrome called Vimium that lets you do some cool stuff in the browser with key bindings, but I hadn't realized that it was actually activating on the Chrome Remote Desktop tab, which is how we're doing the sharing the screen. And so that's why some key presses were getting intercepted. So if anyone else uses Chrome Remote Desktop, if you have some extension in your browser like Vimium. So Vimium is not the only Vim emulator for the browser, but it's one of them. Well, if you have one of those things, you might want to disable it when you're using Chrome Remote Desktop. Otherwise, you end up with bugs like we had. So that's what it was yesterday for us there. And so where we're going to start here today is with virtual environments in Python. So if we go find the folder that we were working in yesterday, we'd made a folder in your downloads folder called Python-example. And if we go find this folder here, you see these folders here that start with .venv right here. This is the virtual environment folder. And so we're going to go ahead and just start fresh today. So I'll go ahead and delete the one that we made yesterday towards the end when we were experimenting there. And so you see there's a whole lot of stuff in this folder, right? And that's because when Python sets up a virtual environment, remember how I talked yesterday about how it's basically building its own box? So you see here is another folder with a dot, so-called dot files are configuration files and folders. So .VSCode is a folder containing files related to configuration for the project in Visual Studio Code. And that one's our launch file, which we'll go ahead and update a little bit later today. So now let's go ahead and we'll open up VSCode on your system again here. So VSCode. And it should probably open in the directory that we have been in for our Python example application here. So here was me trying to test my keyboard towards the end of yesterday. All right, so this was just our normal Hello World application, right? So at the moment, we are just in this directory. Remember, we talked about the command line yesterday, and do you remember what the 3 commands that we talked about were?
Yes, there was ls, there was cd, and what was the last one?
We just had clear, just the command to clear the console stream, right? So we want to see what's in this folder right here, we do ls. If we want to clear, we do this. And if we want to go, oh, I don't know, let's go into the VSCode folder. We can cd there. And then if we ls there, we'll see the launch file, right? And actually, so cd takes in as an argument, it takes in a path, right? And by convention, dot dot means the directory above the directory that you're currently in. So right now, we are in the directory VSCode, and 2 dots means we're going to go 1 directory up, Python example. So actually 1 dot represents the current folder. So if you do dot slash like this, if you do dot slash like this, and then I press tab, it will autocomplete to just the files in this folder. So dot is the current folder. And so we do dot slash, and then I press tab, it will autocomplete to launch, or it would if it was a directory, but CD doesn't operate on files. But dot dot means go to the directory above this one. So that'll be Python example here.
An example.
All right, so that was just, those were the command line things that we did yesterday. So right now, what we are going to be focusing on is making a virtual environment. So if you remember at a high level, what we talked about was that virtual environments take everything relating to an application and they kind of put it all in its own box. So each application is running in its own box. It doesn't care about the other applications or what things the other applications use, because we want all of our stuff to be specific to our application. And the reason for this is if you globally install things, so you install it in like the global scope. So if you try to install one package and then use the same package in different applications, well, what happens if your applications all use different versions of the package? And if you remember, we talked some yesterday about this idea of deprecation, of libraries that you use in your code not always staying the same. Sometimes they make breaking changes. And so if different applications depend on different versions of a library, and you only have one version of the library, suddenly you're going to start getting bugs in your code. And it's going to be very hard to track down and keep track of. And so why not all up front, let's just give each application its own set of packages. That way, when the application uses its libraries, it won't get hung up with other applications. Usually this is just by far the most headache-free way to do this. You want your program's applications to not, or sorry, your program's libraries to not interfere with any other programs. So this is definitely considered best practice. This is what you want to do. If you install things to the global namespace, you don't have to set up virtual environments. Arguably, it's a little bit easier. But the problem is then you start getting conflicts as you build more applications. So we definitely want to start with virtual environments from the very first day. Unfortunately, as you'll see, it's really not that hard. So that is what a virtual environment is conceptually. It's this way to organize all of the information relating to our application specifically so that it doesn't conflict with other applications. We want to keep everything isolated in its own box, staying in its own lane, basically, so that even if we have multiple versions of Python on our system or multiple applications, depending on different versions of libraries, none of that stuff will conflict with each other. So conceptually, does what I'm saying make sense?
I think so. I want to ask a question. I hope will clarify for me. So if we're working in VS Code, for example, and we're building two applications, is that what we're talking about? Like, let me open that. So here, for example, if I'm making the storefront application, then everything we're working with, all the information we're working with is in one place. If I were to be working on another application in VS Code as well, all the information I'm using is also in one place. Is that the sort of thing you mean?
Mm-hmm. So it's actually based on directories. You remember at the very beginning of today, I deleted the directory called venv within this folder. So the virtual environment lives within your projects folder. And so if you have two different projects, they'll be in two different folders with two different virtual environments.
Okay.
I'm not sure if that's answering exactly what you're asking.
It kind of is. Two different projects will have two different virtual environments, right? Okay,
now, you can also have multiple Python files in the same virtual environment.
Okay.
So there's no reason why you can't do that either. It's just the point is it's a way for you to encapsulate a certain set of libraries and the Python version you're running with and all of that stuff. You basically say, this is the standard of the things that I'm using here. This is like my list of dependencies. And so if you have multiple things that share the same list, then they can live in the same virtual environment. But if you have a different application with different requirements, then they'll be in different ones.
I think what I want to be clear about is whether applications here is the same as projects, or if they mean something else.
I mean, so generally speaking, you would want, you know, an application can contain multiple functions that do multiple things, right? And especially as things get bigger, you might break it into like modules. Like you might have one part of your application that, I don't know, displays information to the user, and another part that does like operations, calculations on the information. And you might choose to organize your code into multiple different modules, but they're all part of the same application, right? So I would say if you have one script that is, I don't know, let's say it's doing something with video files. You're like, basically you're sticking video files together on the command line or something. That's what one script does. And then you have another script that like replaces text in some of the text files on your system. Those two scripts have nothing in common. You really shouldn't have those living in the same virtual environment. You should split them up because those conceptually are two separate applications doing two different things, right? So one application can be composed of multiple components, but I would track this in your head by, you know, like actually an application that has a certain set of requirements that does a certain thing. You see what I'm saying?
Would we call the storefront application that what we were working on? And we that's the application. Is that the sort of thing you mean?
Yeah. But I mean, I'm trying to see where the disconnect is here. I mean, I understand it can be a little bit hand wavy because what is the difference? You know, obviously an application can do many different things. And why do we call it one thing if it does multiple things, right? Where's the line between one application and multiple applications? I would think of it like this. If you were a user, would you conceivably ever use one part of it alone without everything else? If the answer to that question is yes, then there are multiple applications. If the answer to that question is no, then they're not. So in the storefront application, would the user ever be like, for example, making a transaction, buying a product, if they didn't have the rest of the storefront running? You know, so they had to be logged in as a user and they had to know the other stores around them and things, right? You see how it's all kind of dependent. And so the answer would be, in that specific case, they wouldn't ever use that part of our application in isolation without everything else. But if you have multiple things that really don't depend on one another, where you might conceivably use one all alone without needing the rest of it, then arguably that doesn't really belong in the same application. So there is.
So we can have a project that's actually made up of multiple applications. Is that it?
Now, there is a design paradigm, especially in web architecture, called microservices. This is getting a bit ahead of ourselves. You may have heard of the difference between a monolith application versus microservices. That is
a bit about microservices.
Yeah. So microservices, the idea is you want to keep each application will do one thing and basically one thing only. A separation of concerns. There's some advantages when you're deploying to the web. Scaling wise, it load balances better. It can handle traffic easier. If one part of your application goes down, so I don't know, something handling like updating user information or something. Well, whatever in the wider application, this network of meshed microservices, whatever depends on the thing that's currently having problems won't be accessible, but everything else will still work. Whereas in a monolithic application, if you get an error, it will take the entire process down. This also gets into how programs run on your computer. You may have heard of multiple processes versus multiple threads. that probably doesn't mean too much to you right now. But
No, it doesn't.
if you have a single process, that means that conceptually one thing is running on your computer. And so if there's an error in that process, if your program's running and there's an error in the program, since there's only one program, it's going to like obviously kill everything, right? But if you have 5 programs running and something dies in one of the 5 programs, then the other 4 programs can keep going, right? As long as they don't depend on the one that died. So there's some advantages to microservices. One downside of it is that, well, you have to maintain 5 separate things and they have to talk to each other. At least much of the time they do. They need to pass information or keep track of state. It gets very complicated very fast. Now we're getting a little bit ahead of ourselves here, but for the purposes of what has its own virtual environment, what is its own application, I wouldn't sweat the details for now. If there's nothing bad's going to happen most of the time if you have multiple things in the same project, because maybe much of the time, maybe one part of your code will use a certain library, but it's probably not going to be used everywhere in your code, right? And so if things have slightly different purposes, as long as they're all kind of working together in one thing conceptually. And like I said, the lines can get really blurry because you might have an application that handles multiple different aspects of something, and each function could arguably be its own thing. But what I'm saying is that there's not a wrong answer to this. It kind of depends how you break down your code and you split it. For us right now, we're not gonna be working on something so big that we're gonna split it into a lot of different microservices. That's just, I mean, like this is not where you start anyway in development generally, because it's more complicated. Like I said, you have to have them talking to each other, and it adds a lot of coding complexity, even though there's like performance advantages to it.
Okay, I think I understand the virtual environment thing a bit more now. So essentially, it's not that your entire code will be operating within one virtual environment, but that different parts of your code, maybe if they're doing different things, will have their own virtual environment.
For our purposes right now, anytime you're writing one project, everything will be in the same virtual environment.
Yes.
As a rule of thumb for now, that's how we're going to do it.
When it gets larger and more complicated, when it gets larger and more complex, then you might have multiple virtual environments for one.
Well, you might, but you might not. There's plenty of large enterprise level applications that are still monoliths. In which case they would share the same package dependency, the same library, because the same thing's running. So the answer is not it's not as clear cut as that. It really depends.
I think I guess it's a bit more.
Yeah. So for now, I would just emphasize that if you have different projects, so it's easy when we're talking about different projects, right? Things that are obviously different. And in those cases, you have different virtual environments. Where it gets messier is if you have one project, but you're splitting it in a certain way. But just don't worry about that for now. That's what I'm saying. Okay. So that's virtual environments. Managing all of your packages and dependencies in one place so that you don't pollute the general system with it and cause conflicts elsewhere. So the command to make a virtual environment, you can just copy this, is our Python program, right? We give it a flag, the M flag for make virtual environment, and then we name the virtual environment, we give it a folder name, and conventionally you put it in a folder that begins with a dot. These are hidden folders, and this is a folder called venv for our virtual environment. So we'll go down in our terminal here, and we're inside the Python example folder. This is where our test.py file is. And so we'll go ahead and we will run this command to make a virtual environment. And so when we run this command, you see that we made the folder there, and VSCode will say, hey, we noticed that you just made a virtual environment. Do you want to select it for the workspace folder? And we're going to go ahead and say, yes, this is the virtual environment we want to use for this project. And then if we click yes there, VSCode will just go ahead and it will do the rest. And so you'll see right here, the shell's actually working. It's kind of building stuff. And you know that because you haven't seen this thing right here, like the prompt. That's what it's called. We haven't seen the prompt returned to us yet. So because of that, we know that it's just sitting here. It's building stuff at the moment. So it'll take it a while because there's a fair bit to scaffold into I mean, we don't really need to worry about what exactly goes on in the virtual environment, but you see now the prompt has come back to us. So that means it finished, right? Okay, so the next thing you do after you build a virtual environment is you need to activate it. Because right now, if we run a command to install a package right now, it's going to install it at the global level because the Python we're using is the global level versions of Python, and it's going to install packages globally. And so if we want to install a package only for this project in this virtual environment, we need to do what's called activating the virtual environment. And so to do that, for us specifically here, this is the location of the script to activate it. It's in our virtual environment folder in a folder called scripts, and the program is called activate. And so if we copy this, remember I said the current file's path is, or sorry, the current directory's path is just a single dot. You see // means we're in the current directory. We go into the virtual environment directory from the current directory, then the scripts folder, and then the activate script. And the directory we're in right now is Python example, and you can see that in the prompt here.
Yeah.
Okay, so we do that, and once we execute that, you'll see now that we have this green thing in parentheses over here telling us, hey, we have a virtual environment active.
Yeah.
Make sense? So now we're actually in the virtual environment here. Anytime we install a package now, we'll install it inside of the virtual environment. We run inside the virtual environment and things like that, okay? So that really wasn't so bad, right? 2 commands, right? 1 command to build it the very first time, and after you build it, you never have to build it again. After that, the only thing you need to do is when you're starting up your project, you just need to remember to activate your virtual environment so that the things that you do to modify packages and stuff only happens inside of this specific space. And that's it. For now, for our purposes, you don't have to worry about anything other than that. Just make sure you remember to do it, and that will keep everything nice and sandboxed on your system. And that way your projects will never conflict with each other. But it's another step in what we need to do to properly work on Python projects locally here. So that's why we had to cover it. All right, so do you have any more questions here, or are we good to go ahead and move on?
Just for clarity in my head, the / bit actually says we are still in the Python example folder. Within that folder, find scripts, or rather the virtual environment, right? Within the Python example, we find the virtual environment folder. Then in the virtual environment folder, we find the scripts file, right? And then deactivate scripts.
So over here in the sidebar, we can actually go find this. So this is what happens when you expand the virtual environment folder. So right now, the folder that's open in the sidebar is the Python example folder. So this is its absolute path on your file system. So we have the C drive, users, and then your name, and then downloads, because we put it in the downloads folder, and then Python example. That's the name of this directory here. And then inside that, we have the .venv folder, which includes a scripts folder, and the scripts folder includes something called activate. So there's a batch file and a PowerShell script, probably running the PowerShell script here. So if we wanted to deactivate, go ahead.
So when we do the // what we're actually saying is that we are still in the Python example directory. Okay.
Now it will work fine if we don't. So the thing is, I autocomplete it, and when you autocomplete, so let me type it out. So if we want to deactivate, we can go to the scripts folder again, and then there's a script called deactivate, which will deactivate our current virtual environment. So this time I didn't put well, I guess we don't have the deactivate here as a maybe can I control C out of it? No. If I type exit. Well, that gets rid of the terminal completely. Not entirely what we wanted. Now we reopen it. Now we're not active, but all right. Well, anyway, basically, VS Code's smart. There's no reason why you'd want to be inside this folder without your virtual environment active. So I believe VS Code's smart enough, at least I think it is in my project. And I think once you associate the virtual environment with this folder, whenever you open this folder in VS Code, it will activate the virtual environment for you. So you never have to actually remember to do anything to it again.
Okay.
Okay, so that's virtual environments. Now they'll become important in a second here because, oh my goodness, why is it? Well, I guess I can't scroll through it. So we were just talking about virtual environments. The next thing that we're going to do before we get into packages here is we're going to set up a way to launch our file. So if you remember right now, if we press F5, that's the run command here, or we go to this view here, we have something here. This is called a launch configuration for launching the current file. And so if we had more than one Python file, it would only ever launch the file that we were currently in, which isn't necessarily what we want. If we had a main application file, here, let me actually do it just so that you'll see. So, oops. Let's go here and let's add a file called file. Use an underscore child file.py. Okay, so this could be like a library or something. And so we could just print here, like inside file. Okay. And inside test.py, let's say this was our main file, we could print right here. Okay. So if we are inside this file in the text editor, these two files will be different. So if we are inside the child file right now, and we use the launch configuration that runs the current file, you'll see when we launch here that what gets printed out should be inside child here. So it's going to activate the virtual environment, and then it's going to run child file. And so you can say inside child. Okay, and that's because we launched our launch configuration inside of that file. Now, when we have this file active and we press F5, it's going to say inside parent because we're going to run it again. So we get that out of the way. We're going to run it again, and now it says inside parent, right? Okay, so you see what happens if we always want to run the same file, no matter where we are. Because very commonly, you'll be breaking your code into multiple different files, and then you'll import stuff from one file to another once your project gets bigger. Most of the time, you want to be running your project as a whole, right? Not just the specific file you're in. So let's go ahead and, so if we want to add the configuration, this is going to open up the launch.json file here, and this is what it looks like. So the file here, it says, is going to take in this thing right here, rather than being an actual path right now, is just taking in the current file. So let's change this to say run the test application. That's what we'll call this. And then rather than passing in the current file, that's what this thing does right here with the come on, don't hover, with the file injected into the parameter there. Let's just type in test.py. So from our application folder, this takes in the path to where the file that we want to run is. And so, let's just call this, rather than that whole long wordy thing, let's just call this test like that. And so now we just modified it so that our program will always launch test.py, which will contain the main program rather than the child one. Okay, so if we save this file, like I said yesterday, this is a JSON file. A JSON is, you see these curly braces and brackets and stuff. That is the syntax specified for storing information in JSON. And so this is used for configuration of setting up. Now you could have your different things set up here. So right now we just saved this, we called this test. So if we run test here, and this is the configuration that we use for launching, then you'll see that this should print inside parent, because we're just going to run test.py right there. Okay. And so now, no matter which file we're in, even if I go over here to the child file and I run the program when I'm inside the child file, like I am right here, it's still going to print the parent one, because we set up our launch to always execute the parent. Does that make sense?
Okay. Yes. So that means that if we make a particular file the main file, that we always want things to run there, and build things like this child file, let's just say child files like that, what we would do is actually kind of connect the files between them and the parent, so that when you want to run the main program, it actually runs all the stuff in the other files when that's needed. Am I getting?
Okay, so let's say in the child file, we define a function like this, print message, okay? So it's not going to take in any parameters. We're just going to print the string hello world, okay? So print hello world, very normal, beginner application here, okay? So this is the only thing for now that we'll have in this file. So right now, the child file just contains a single function definition, right?
Yes.
So now if we come over to our test file over here, what we can do is we can say from, so we can actually import that function from child file. At least I think this should work. We have print underscore message. Now, we'll find out real fast if this will work or not. It might say it can't find it. Oh, nope, it works fine, right?
It works, yes. So that's the idea of having multiple files like that and deciding to make one. Having one that always runs if you set things up like that.
Yep. And then you'll import things from your library, your modules that you write into your main program file. This is the way in which you write programs 100% of the time. If you have a big interconnected program, you'll break it down into smaller bits and pieces so that it helps you think about it, so that it's easier to work on one thing at a time. And then you'll combine it all in your main program. That's the one that you will always run. So in the launch setting here, maybe you don't call it test.py, maybe you call it main.py, maybe you call it whatever, but you'll almost always be running just one file 100% of the time. And you don't need to worry about other things for now. I mean, eventually launching it, you might launch it in a debug mode versus a release mode, or launch it in a different environment for comparing if you're deploying to a server. We're not going to worry about any of that for now. For now, you're going to pick whatever file you're designating your main file. You're going to set up a launch configuration for that, and then you'll reference any other files that you write in your main file.
Sounds, I understand it.
Okay, great. So now we've set up a launch configuration. We can run our application here, our test.py application, just by going to the run menu here. I mean, so that's Control-Shift-D if you want to always just pull this up immediately, or you can just press F5 and it will run the currently selected launch configuration, which is, we only have one right now. So yeah, we'll get more into hotkeys and stuff later. Very useful because they save you a lot of time once you memorize them. All right, so that is setting up our launch configuration here for our application. Oops, forgot I can't use the scroll wheel because of whatever bug. All right, so now that we have our application up and running, the next thing that we might want to do is we might want to install a package. So packages are programming libraries. They're code that other people have already written. And as much as possible, we don't want to reinvent the wheel. So if someone else has already solved a problem that we want to solve, why don't we just use their code rather than writing it ourselves, right? It saves time and just makes lots of sense, right? So what you see right here, pypi.org. I'm not actually sure how you pronounce it. I've only ever seen it written PyPy, maybe. That's probably how I pronounce it, PyPy. The Python package index. So PI is an acronym, stands for package index. This is where you go to find packages that you might want to use. So like trending projects, well, TensorFlow, very famous thing for machine learning. There's another package called NumPy, like NUMPY. That's used a lot in data science stuff. Different packages used for different things. Most of these things probably don't mean too much to us. Cryptocurrency trading library. Interesting, huh? If you want to trade cryptocurrencies, now there's a there's a Python package for that. And what you'll realize very quickly, especially for popular programming languages, Python is among the most popular. So Python, C#, JavaScript, Java, C. I'd say probably those are the most common production languages. I think probably I'd have to go look at the statistics, but JavaScript is probably the most common. Python may be second. Java, C# are up there too. All of these things will have packages to do most things you want to. Every once in a while, you will have to write stuff yourself, but many of the things that you would want to do, someone else has already written the code for. Now, what your responsibility as a developer will be is you need to go find a package that does what you want, and then you have to read how to use it. Because even if someone else has already written the code, you need to know what inputs to pass the functions, for example, and what the functions will return and the format that they'll do things. And you see what I'm saying, right? Like just because someone else has already done the coding part of whatever you want to do, you still need to understand how to use it. And so this is where you go. And actually, not here. I would not usually recommend that you go straight to PyPy and you try to find something. What I would do is I would 100% Google, how do I do X in Python? And on Stack Overflow or some other site, you'll come up with someone saying, oh, just use this library. And then you go search for the library on PyPy, right? And the reason why we do this is because you can find the official package, the package names here, and you'll find the command to install them. So I'll give you the example that we're going to use. We're going to use an example here for making a string URL safe. So it's called slugifying the string. So a URL is this string that we put up in the address bar in our browser, right? And you see right here, it says programming teaching series, right? That has dashes in the path. Well, you don't have spaces inside of URLs. I don't know if you've ever noticed that, but you don't. And so there's a certain way in which they're formatted, right? And we're not going to worry about some of the icky specifics of this, but we're just using this as a simple example. So if we want to take in an arbitrary string and we want to convert it in the format that will be like valid to use in a URL. So actually the slug is not this full path because we have things like the domain name up here. The slug would just be the path. Once you're in like the file structure part of it, it would be like this. Rather than like the domain name and the connection type. So if you were HTTP versus HTTPS and stuff like that, or the port number, we're not going to worry about any of that. The slug is just like the name of whatever it is you're doing, right? But if you have spaces in it, it's not going to be a valid URL, right? So if we want to take in an arbitrary name, maybe of a file or a path on our system, and then we want to make it in a form such that we can publish it to the internet, it needs to be a valid URL, right? So that's what this package here will do. So we'll go open this package on PyPy, Python-slugify. It's a package here that takes in Unicode strings, and then it tries to create a slug for it, something that you can reference in a URL. So you can see that there's a version for Python 2 and a Python 3. Of course, we'll get the Python 3 version when we install it here. And when you go find it on Slugify, right, you can see that, like there's some information about who has this. If we want to go look at this, we could probably go see if we go to the homepage, it looks like this project is hosted on GitHub, which we'll talk about towards the end of today. This is one of those code repositories online. So you can see the guy who maintains this, has, a number of commits to it. And the last commit was like, it says like 26 days ago or something. And, you can see all the information. This is the package. Someone has made this free to use, and you can check the license on it. That's actually kind of important depending on how you're using your project. So, different kinds of software licenses. I don't want to get off too off topic here. If you see a license that's either MIT, that's this one, or Apache, or what are other common ones? Those are probably the two most common, like so-called permissive licenses, where basically if something's licensed on MIT, when you use it in your own code, you have to say, hey, I got it from this guy. I didn't write this. You can't like claim it as your own code, but that's about it. Like you can use it for anything, commercial applications, whatever, open source, right? And licenses that are more restrictive, there's a license called the GPL license put out by the GNU Software Foundation. So GNU is the acronym there. The GPL, they're on version 3 now. The GPL v3 is a so-called copyleft license that basically, whenever you use that license, anything that uses code that's licensed under that also has to be open source and copyleft, has to use the same license. So it's popular in the free software community that's like really big on like privacy and open source everything. But it means that commercial applications will tend not to use their code. I would say the vast majority of stuff on GitHub is probably MIT or Apache. I have to go check the statistics on it, but these are the open source licenses that are basically like, yeah, just make sure you give credit where credit's due, but other than that, you can use it to your heart's content. So this one's MIT, right? This is the package. I mean, you see they have some examples here and, like different parameters, and we're not going to do anything complicated here, right? So there's some regular expression matching and stuff, but so that's where this package lives. But to install it, we go on PyPy, you'll see that it just gives you the pip command, right? So we are using pip as our package manager here. There's other ways to do it, but for now, we're going to use pip. And so this will be the command that we run here. Pip install python-slugify. That's all we need to do to install the package in our virtual environment. So here we are. If we go back here, you'll see that now in our terminal, we have our virtual environment active, right? So we have this venv active in green over here. We just copy paste that in here, and we say pip install python-slugify. This will actually download the package for us. And well, okay, I guess you have. I just X'd out of that. I don't know if it'll work. Well, it looks like it's going to work okay. So downloaded it, successfully installed. And you see it installed a dependency. There's a reason why I picked this one. See text dash uni decode right here, that package. Well, you might say, but Stephen, we just installed this package. Why'd we install something else? So this is the idea of the package dependency. This is one of the reasons why managing packages is such a pain in the butt, because if one package depends on a certain version of something and another package depends on a different version of it, you might end up with two versions of the same library, neither one of which you actually thought that you needed because you didn't say install this, it just got installed when you installed something else, right? So hopefully what I'm saying, maybe this doesn't sound so bad to you right now. I guarantee this will cause pain and suffering no matter where you work. Dealing with packages and wrangling packages and dependencies for packages, and somewhere, sometime, something will get messed up, I promise you. It happens frequently enough that everyone has to learn how to deal with it. It's just one of the headaches of being a software developer. If your application gets big enough, especially so that you have multiple dependencies and you're relying on a lot of other code, each one of those things will have its own package dependencies, which may have their own package dependencies, and you get the idea, right? It gets very complicated very fast. And easy for stuff to get messed up. Now, it won't always get messed up, right? It's not always doom and gloom, but it's just something to be aware of, right? So when we installed this, you'll see how there's a number on the end of this. This is the version number, and this will be important. We'll talk about this towards the end of today when we talk about freezing packages and setting them up in our requirements file. So anytime this package, the Slugify package here, gets updated, we don't necessarily want to just automatically use the updated code in our application, because what happens if it breaks something, right? Remember, we've been talking about that. Stuff gets deprecated, or they add new features, or they change how they do it. So in our application, we want to use what we know works. So if we say, I'm going to use Python Slugify, whatever version, I'm going to keep it at that version. Now, one exception to this is you generally don't want to let your versions of things get too out of date, especially if they're part of your application that deals with security, because there will be security like patches. There'll be bug fixes or improvements related to security matters. So especially if you have a package dealing with like network traffic or something that is like security related, you will definitely want to keep those things up to date more. And it's just generally considered good practice to not let your packages get super, super out of date. But anytime you bump the version on something, you might have to go fix a bunch of places where it breaks stuff. Kind of unpleasant, right? This is part of software maintenance. So I don't want to get off on too big a tangent, but I think I've kind of got up on my high horse a couple of times and mentioned how software maintenance is like a way bigger part of the software engineering lifecycle than actual development is. So you will spend more of your time, especially if you work for a big company who has big applications, you're going to spend more of your time dealing with something that already exists than you're going to be writing something from scratch. And a big part of the maintenance is, well, when the application was written, we wrote it in Java 8 and like Angular 5, for example, and now we need to update it to Java 12 and Angular 11. And when you do that update, you might think, oh, well, everything will just work. Well, no, it won't. You're going to have to go fix all the places where it breaks when you update the versions on stuff. So that's enough on that. So this is packages. This is our introduction to packages. And so now these are packages that we can use. And so I have an example application that we're going to take in now where we use the Slugify package here. I'm going to remember not to scroll this time. So here's our application. So we're going to import the Slugify package. That's the one we just installed. And then we're going to have a function called makeURL that takes in an input string, and then it slugifies the input string to make it valid. Okay, so in our project here, we'll go, we can actually do this in the child file, right? There's no reason why we can't. So we'll replace that very simple function that we had there with this. And so we'll import Slugify here, and Python will know what this is because we have the Slugify package installed in our virtual environment, right? And I'll show you two different ways of calling this function, right? So this is going to import the Slugify package, and the Slugify package defines a function called Slugify. So we do package.function name, and we give it our input. So that's how we're going to call this right now. And over here, we're going to go make our URL. So we no longer have that function name. Now we have something called make URL. So we need to make sure that we're importing the right thing from our child file here. So we're, instead of importing print message, we're going to import make URL, and we're going to call make URL with, oh, what shall we do? Something like, this is a file name. So we need to make it a string. Okay, so this right here is not something that can be part of a URL, right? It's got spaces, it's got an exclamation point, right? So let's go ahead and let's print what happens when we make this a URL, right? So that should, how this will run, when we run the test.py file, because remember, that's what we set up in our launch configuration, it's going to run this file, but this file imports a function from the child file that we have, which imports a package, defines a function that calls the package to modify the input string. Does everything I just said make sense?
Yes, it does.
Sounds really complicated, right? But you see, we only have like 5 lines of code here. But this is why it's so important for us to understand what's calling what, why does it call it, how does it work, how does Python know where things are, right? If you actually understand how this runs, you're going to be good to go. Basically, your programs can get pretty large. You can make lots of different function calls, but the actual mechanism for how things are connected won't be much different than this, like ever. Like this is how Python knows how to call libraries and how you call local code files here. You do import statements, right? So if you want to import a function, you do from module name import function name, right? That's this syntax here. And over here, we have just import module, and then you call it as module.function name. So typically, this format right here is what you'll do, because usually you won't need everything that's in a module. You'll just need a function or two, right? But I started us out over here with the whole module just to show you that it does work fine if you do it this way too. It just, usually it's considered uglier, because then you have to like put the module name in front of the function every time you call it, right? Okay, so let's go ahead and let's run. I actually haven't run this. I really hope it works, because I was just coding this off the cuff here. So
it worked.
It did, right? And you see, this is a file name exclamation point gets turned into this -is-a-file name, right? And that is
Yes.
something that would look just fine in a URL, right?
Yes. Okay.
All right, so let's go ahead and let's try doing the more elegant approach here. So we know that all we want to do with our Slugify package is we want to call the Slugify function. So what that means is that we want to do from module name. So our module that we've installed is called Slugify. And you can just take my word for it, but the function that we want to use from the Slugify module is, well, it's actually called the same thing. It's called Slugify. But if we do this, we don't have to include the module anymore, right? So we're saying from the Slugify module, import the Slugify function. And now it looks prettier, right? And this is especially important once your code gets bigger, right? Right now we only have like one thing, so it doesn't really matter that much, but eventually you might have a whole bunch of different library calls that you're making, and it's much more convenient to call it this way because it's easier to read in your code. It's not so cluttered, right?
Yes. Yes. Okay. I understand that. The two Slugifies mean different things. One of them is the actual thing we're using, and the other one is what contains the things.
Yep. So the official terms for that would be the thing that contains the thing. It's called the module or the library, right? And within that module, within that namespace, you might also hear it referred to as that is a function or a method, and that is what we're calling, right? Because you invoke or call functions and methods with arguments like this, right? So open parentheses, close parentheses, we're calling a function here. It's contained inside a module that's actually kind of confusingly named the same thing. Generally, actually, probably kind of frowned upon. If you can make your module not the same name as functions in it, it's probably better, because then at least it's a little bit clearer to people, right? I mean, this isn't wrong. There's nothing wrong with it. It will work just fine. The compiler or the interpreter for Python will know the difference between the two of them, but I didn't know the difference because the syntax of this statement here is from a module, you import a function. That's how this reads. That's how the interpreter interprets it. So you never write from function name, import a module. That doesn't make any sense, right? Because functions don't contain modules. Modules contain functions. All right, so we'll just keep on going. Nothing we're doing today, I hope not. I hope nothing we're doing today is super duper hard. This is just all the basic framework stuff that you need to write Python applications locally in your VS Code environment, in your virtual environment, setting everything up, getting it integrated. Now you know how to find packages. You find Stack Overflow that says, hey, you should use this package. You go look the package up on PyPy, and then you find the pip command to install it. After you install it in pip, you can then reference it by importing it. You do have to use the import statement. You can't reference it before you import it, but after you import it, then you can use it in your code as if it were your own code. So very critical part of programming is learning how to use other people's code so that you don't have to do it all. Don't reinvent the wheel. I did it again. All right, so we only got a couple more things left. The next thing that we're going to talk about now is we're going to talk about keeping track of all of the libraries that we're using in a requirements.txt file. So let's say that you've made this application here and you want to send it to me. And I want to be able to run your application. Well, right now we only have one library file. So you might say, hey, Stephen, you just need to go download the Slugify package, right? So as long as you download the Slugify package, you should be able to run my code and it should work just fine. Because what happens if you try to run the code without having this package installed is you'll get an error. It'll say, I'm sorry, I can't find Slugify. What's Slugify? And so that's what will happen if you don't install the package first, right? And we installed the package with the pip package manager for Python, but when you share your code with someone else, their system is just not going to inherently have that package, right? And so you could tell them verbally, hey, you need to download this before you run my application. But what happens when it's not just one package or two packages? What happens when it's like 50 packages? And also don't remember that to run our application, you might think, but you see, I'm only importing things from one place, right? But you remember how actually two things got installed, right? So when you share your application with your friend, actually, you can tell them just install Slugify, because when they install it, it will install the other one. But technically, they're actually installing two packages. And so all of this is the reason why typically you want to track which packages you're using somewhere. These things are called configuration files, right? We have a configuration file for setting up our launch, the specific parameters of how we're launching our application. Well, we're going to have another configuration file for specifying which packages we're using and what version of those packages we're using, right? So I've made a pretty big deal today talking about how important it is to keep track of your packages and which versions you're using, and not just automatically bumping versions because it might break stuff and all that. So Python's way of doing this, they typically, I mean, it's different across different programming languages. There's some patterns here. Many programming languages might use like an XML document for this, a project file or whatever. That's what C# does. But for us here, we have a text file that contains a list of packages called requirements.txt. So the way in which you want to make this file, you should not make this file by hand. Let me repeat that. You should not make this file by hand. Whatever package manager you're using will have a way to freeze the packages that your project is currently using, and you will want to use that command to build your requirements file, because the program's smarter than you. It knows exactly which packages and which versions you want to use. Now, you can update this if you want to say, hey, you should have this version of this package or greater. Maybe you do that, or this version or less than or equal to this version or exactly equal to this version. Like, you can tweak stuff about that. So I have a good link here, someone's blog. And on this person's blog, they go over some of the stuff you can do. It's being kind of slow. Come on, let me click. Well, lag. So this person has a good guide to it. I'm just taking the main takeaways, but I think they have some examples. See, here's the comment. So a version matching, minimum version excluding, anything but this version, compatible version. You get the idea, right? This is the syntax for it. We're not going to worry about it. For our purposes, you really don't have to worry about it. You're just going to always say, hey, I want this version. And that's what most people will use. Like 90% of cases, that's all you care about. So we're going to let the package manager build our package file, basically. So we're going to copy this command here. It's called the freeze command. So we're using the pip package manager. The pip package manager has a command called freeze, and we're going to save the output of this into a file called requirements.txt. Now, for now, you can just copy paste this command. I don't really want to get into this thing right here is actually directing the output of this away from the command line, and it's going to output it into this text file. If you don't have this, it will just print it to the command line. So this is so-called redirection operator, but don't worry about it. For now, just copy this command and use this command. So we're going to go into VS Code. We're in our virtual environment, right? So now we've installed the package, we've run our application. We want to be able to share it with someone else. So we're going to go ahead and we want to build this file called requirements.txt that will contain a list of the packages that our program depends on. Okay, so we run that command, and inside of our project, if we go look now, it made a text file called requirements, right? And if we open this text file, hey, look, there's our Slugify package. And here's the thing that the Slugify package depends on, right? And it says version double equals these. So to run the application that we're building here, you need the python-slugify package and the text.unidecode package, right? Which is a dependency of this. But, in the requirements file, this is how it will install them, okay? So what we just did makes sense, right? We took the packages that we had in our virtual environment and we ran a command with our package manager that said, hey, I want to figure out what packages I'm using right now, and I want to save those to a file. And then I can share that file with other people, okay? So now let's say that you sent this to me and I'm on my installation and someone else gave me a requirements.txt file and they said, hey, here's my application, here's all the code I have, but you need to install your packages first. So to do that, you're also going to use pip, right? So we saved them with the pip. We're going to install the requirements file. So pip has another command called install. So we have the freeze command, we have the install command, right? For now, don't worry about the -r. That's a command line flag telling us to do it. I think it's recursively. I'm not actually sure what the flag is, whatever, I could look at it. But we go here to our virtual environment, right? So let's say that I didn't have these, right? In fact, I'll show you what happens when we do this right now. It's going to say, hey, you already have these packages, basically. It's not going to like error. It's just going to be like, nah, we didn't do anything. You already have it. right? But if we didn't have these packages, then it would install them for us, right? So it says requirement already satisfied. We already have this package, and here's where this package lives, right? So saying that it's already in site packages for us. But if we didn't have these packages and you sent me this file right here, I would actually go ahead and install the packages. So do you want me to show it to you? Like we could make another Python project and take this requirements file and then run this command and it would install the packages, or you can just take my word for it that it does that.
I think I get how it works.
Okay, so you know what, maybe as an exercise, you can make a completely separate Python project. And in fact, I think that's what it would be good for you to do. We've done a lot of things, right? We've set up the launch configuration, we've set up a virtual environment, all of these things. You want to do these at the beginning of when you set up a new project. So probably before we next meet, I'll have you go ahead and just make a new project. Doesn't matter what the project does. It can even just be a hello world application. But for that to be correct, for you to get full marks, you're going to want to make a new directory, set up a virtual environment, set up a launch configuration to run just the main file, install a package, and then get a set of package requirements and put them in a text file like this so that anyone else who uses your application will be able to install the requirements, right? And all of that, once you've done all of that, you're kind of finally done. Now you're ready to go develop your Python application. And then you can share it with people, right? So what we're going to close on today then is we're going to talk about version control. Okay, so now great, our Python environment is set up. We have the ability to run it in a virtual environment where we have all of our packages and we've frozen our packages. We put them in a list so that someone else can use our application. Now they can install all the package dependencies. So we're ready to go write code, right? But then the question is, how do we share code with others? How do we develop our project on a team of developers? And that's where this thing called version control comes in. So today we're just going to go ahead and install things for you. We'll talk about next time we meet, we'll talk about how you use it. This is pretty complicated. We'll go over some of the more basic cases, but there are some parts of Git that even I try not to touch too much just because it gets very confusing and it's kind of buggy. Not buggy. Git's not buggy. There's millions of people use it, but like it's easy to make mistakes with it. But version control is a completely essential part of being a software developer on a team. So if you're on a team of software developers, you're going to be all working on the same project. You might even be working on the same files, and you want to make sure you don't step on each other's toes. And so how do you do that? You track the changes to your files over time with a version control system. So Git is a version control system. There's others. Subversion and Mercurial are probably two of the other famous ones, but Git probably is the most popular, probably used by the most projects. So version control systems at a high level, they track the changes that you make to files over time. So they show you what you've added and what you've removed from files, right? You and everyone else on your team, right? And so today, like I said, we're just going to be downloading and setting up a couple of tools. We'll get into specifics next time. So the first thing that we're going to do is we're going to go ahead. Well, actually, first, let me check if you have it. I guess we'll find out. At a high level, any questions while we're waiting on this to pull up? Any questions about what version control is or why we'd use it? And if you don't 100% get it right now, it's fine because we haven't really done any examples with it. But yeah, you don't have it. So.
I don't have a question right now. I think I get the concept of it.
Okay. So we're going to use Git. It's the one that
a little like working in a Google Docs with other people. That's how I'm thinking of it. So, except that, of course, some that Git gives you a record of changes that have been made. Well, Google Docs does.
Well, it kind of does, but Git, you structure the changes that you make into things called commits. And so you may have heard this before. A commit in Git is basically, it's a set of changes, a change set. That's what a commit is in Git. And the other big difference between Git and Google Docs is on Google Docs, everyone is sharing the same copy of stuff. In Git, there is one centralized copy on your remote Git repository, and then everyone else has a local copy where they can do stuff themselves. And I mean, I don't want to get too off in the weeds here. Git also has things called branches, which is basically you take a copy of a project and then you clone it, and then you do stuff to the clone. And before you change the original, you want to say, hey guys, do you like the changes I made? And then other people can approve your changes or reject your changes. And if they approve them, then that branch that you made, so-called it gets merged into the main branch, right? So that change set that you've adopted, or you might actually have multiple changes, that multiple commits on a branch. If that gets merged back into the main one, then you change the shared version. But otherwise, you're just changing your version. So if I lost you there, don't worry. It's not the easiest thing. Once you learn it once, you're good though. And you'll use it all the time. So now we may as well just install it as a normal setup. You can also install a portable version of it if you want to run things off a flash drive. I don't think we care that much here. So we'll go ahead, we'll save the 64-bit installer here. You're probably gonna have to enter your, admin password and all that great stuff for us setting it up. Okay, so this one is an installer. We might be able to install it with Chocolatey. I guess I just haven't ever bothered because I don't know. I've installed it with the installer before. It's really shame on me. I was encouraging you to use Chocolatey the other day, and here I am not using it. But
we could have used it to do the installing, is what you're saying.
Maybe. I'm not actually sure. Chocolatey doesn't have all packages like ever. It has many things, but it doesn't. I mean, like honestly, you're never gonna really update Git. I mean, you probably can, but yeah, I mean, like it's been around for a long time, since the 1980s, I think. So, all right. So here's that. You remember I said the GPL, right? Oh, look at this. Git is licensed under the GPL version 2, open source software license. So.
Okay.
Lag. Actually, I can't touch that window. So you go ahead and you do this. Okay. You can press next. That's fine. Press next. Let's see. Okay, so if I were you, I would uncheck the Windows Explorer integration. You don't really need that. And yeah, that's fine. Okay, so you can press next, and that's fine. That'll let you open it from the start menu. I would go see what's in that dropdown. You probably don't want Vim. I would use Visual Studio Code. Yeah. That's fine. So tell me if you can figure out what this is saying. This is related to something we talked about yesterday. So
Okay. This option adds only some minimal Git wrappers to your path to avoid cluttering your environment.
So do you remember when we were talking about the path yesterday and what the path represented?
Yes. Essentially, let me see if I can put it in words that make sense to me. Okay, so the path is okay, so the way I'm thinking of it is this is how the computer can actually launch something, run something. Mm-hmm. That's how I understand the path. I'm not sure if I'm getting that quite right.
I mean, it's the set of things that the computer knows how to execute, right? You point the computer to, here's the things I want to be able to run, right? And so the difference between the first radio button here and the second one is if you check the first one, it's not going to actually add Git to your path. It's only going to add it to the environment variables for one specific shell. and that's git bash, which I'll show you in a sec. The second one is, well, you might want to be able to use git no matter what command line you're on, right? That's why this is the recommended one, right? Is that this will let you use git no matter what shell you're in. So PowerShell, command prompt, and git bash will all let you use git. This is probably what most people want. But what it will do is it will add the path to git to your path variable, your system path variable. So if you didn't want it on your path, well, suddenly now you have things there that you added, right? So if you want it, it's great. If you don't want it, well, then you wouldn't want it there, right? That's why they give you the choice.
Okay.
We're going to want it there because the default terminal in VS Code, I think, is PowerShell. And so we're 100% going to want to be able to do git stuff, right? So if you want to leave that one checked, that's the right one. Okay, that's fine. That's fine too. Yeah, keep that. Hey, keep that. Keep that. That's fine. We're going to be using an SSH key eventually anyway. That's fine. Don't worry about it.
I shouldn't check anything.
Yeah, don't check anything. Those are like beta features. Just go ahead and press install. All right, so I'm just going to install some library extensions here. This will probably be the biggest thing we install now. Can you go ahead and click on your browser again? So that I can do things again. All right, so we're going to go ahead here and we're going to look for another application called SourceTree. Now, SourceTree interfaces with Git. It's like a graphical user interface for it. So Git is a command line program for the most part. But what happens if you want to be able to see the changes that you've done like this? So you see this, it tells you what you've added and what you removed in this nice pretty file. It shows you where the additions are and stuff. And you can see all the files in your change set, blah, blah, blah. SourceTree is one of the two big graphical user interface front ends for Git. Another one is called GitHub Desktop. So obviously GitHub Desktop is made by GitHub. SourceTree is made by a company called Atlassian that runs basically a competitor to GitHub called Bitbucket. We actually use Bitbucket at work. Previously, we were using Microsoft DevOps, but you know what? You don't care about any of that. I use SourceTree. It's the one I'm familiar with. They're all basically the same, so it really doesn't matter that much. But I'm actually pretty opinionated about this. I really think that for most people, it makes sense to use one of these programs rather than doing everything on the command line. Sometimes you may want to hop on the command line if you want to do something more complicated, because the command line lets you script it. You can use multiple arguments, et cetera, et cetera. But for general day-to-day use, I recommend most people use one of these visual programs, just because it makes it easier to think about and see. So we're going to go ahead and we're going to install this as well. So if you want to go back, let's see what the progress of our Git installation is here. Okay, so I would go ahead and check that launch git bash, and it will open up a terminal when we do this. And so now you will have a new shell on your system. So we installed this thing. Hopefully I can touch this window. Yeah, okay, good. So you see, this is actually a Unix shell. We'll get into that eventually. PowerShell is actually a different shell language than Bash is. So this is called a Bash shell. Bash is one of the most common, probably the most common shell scripting language. a shell scripting language is kind of like a programming language, but it's kind of suited for doing stuff on the command line. There's actually a large segment of people who think that shell scripting languages are stupid and we shouldn't have them. And so there's some people who made a shell for Python, basically, where you just write Python on the command line because, that makes sense, right? Why are we learning a separate thing? And also the way in which Bash makes you do things is like really confusing in some ways. And so why don't we just use a real programming language? There's also other shells. There's like a C shell where it lets you write C on the shell, although Python is much prettier than C. So if you're going to pick a programming language shell, I'd 100% go for one of the Python ones, although it's a little bit slower, of course. But at any rate, this is Bash. So if we ls here, you're in your home directory. And so this is the same thing as what you had before. It's a little bit prettier. See, it's got some, like colors here for different folders and stuff. And so if we want to cd into documents, we can still do that. We can still ls, we can still clear, right? All the same stuff. Okay, now, but what this will let us do is if I go back up, remember I said ... takes you back to the parent directory, right? And I want to go in the downloads folder. Okay, well, I was going to say I can't find that. So downloads, right? Then I want to go into our directory for Python test, right? So we have Python, what we called it, right?
That's an example.
Oh, I think we call it Python example. Yeah, you're right. Okay. All right, so now we're in this directory. Here's what's in this directory, right? So, this is a command. Cat is a command on the command line that shows you what's inside the file. Basically sticks it on the output. So that's the file. We know we're in the right place here, right? All right. So just to test our Git, there's a command for Git called init. This will set up the scaffolding for a Git repository for whatever folder you're currently in, right? So we're in this Python example folder, right? To test if we have Git or not, we're going to go ahead and run the git init command. And then if we ls again, you should see a .git. Well, don't worry about that for now. This shows hidden commands and folders. The -a stands for all, the -l stands for like the list view that shows us everything, right? But you see how now there's a folder here called .git. So if we go open this up in your VS Code, it'll be clearer in VS Code. Actually, VS Code won't show it because it has a separate thing for source control here. I think it just needs to be updated. Now it should probably show up. Okay, yeah. So now source control is there. If we go to the file tree, what I just did was I ran a command called reload window here. If you press Control-Shift-P in VS Code, it will take up a command window here that lets you run a bunch of different commands. Control-P in VS Code will let you search between files. Now we'll get to all that later. Okay, but anyway, in Git Bash, we've now made this new folder here. You see how it says .git, right? That means that now this thing is a Git repository. And so, so I suppose I don't need the L. If I just do A, now you see that Git's there, right? All right, so that means that Git is set up and it's working properly. And we could do more things like commit and push and merge and stuff, but we're not going to do any of that today. We just wanted to make sure that we got it installed. So now we're going to download SourceTree. What was that? That was the release notes that we had. So we're going to go ahead and download SourceTree so that we have a visual front end for this. Blah, blah, blah. Assuming you are fine with their software policy, which is normal stuff. Okay, so we have another setup thing here that we're going to download. And then you're probably going to have to do this again. I mean, it's kind of logical, right? If you're sharing someone's screen, that they wouldn't let me just like take over control of your computer and install whatever I want. It's kind of a security risk.
Yeah.
No, I can't see anything that's happening right now. Maybe it's just being slow.
Yeah, it's slow. It's actually Right. Okay.
I would say install anyway. Yeah. So are you on Windows 11 then?
No, this is Windows 10.
Windows 10
I
still. Okay.
have
Yeah. Just
the
wondering,
requirements.
because that didn't look real familiar to me. All right. Well, looks like it's opening. That's what the normal opening looks like. Or is it just going to be an installer? I guess we'll find out in a second.
Okay. So there's Bitbucket server, Bitbucket. Do I do anything with all that?
I guess you're going to have to create an account.
Okay.
So I guess we'll have to do that. You know what, let's pause the recording real quick and we'll go ahead and do that off screen and then we'll pick back up. We'll pick back up once you've done that. All right, so we picked up, have SourceTree installed now, logged into an account with the Atlassian folks. And so the last thing that we're going to do here today is we're going to go ahead and we're going to add the new Git repository that we just made. If you remember, we on the command line here, we did a git init and we made an empty Git repository in our folder for our example Python application. So we're going to go and we're going to actually get that imported into our visual Git tool here. So we're going to go to downloads where we have it right now. And we have our Python example. And this is the folder in which we have our Git repository. So we're going to go ahead and we're going to add this, right? And it would give you an error. It would give you an error if this wasn't a Git repository. It would say, hey, you can't do that. Okay. And over here, it's going to show us all of the files that we have staged. And you can actually see these are all the files that are living inside of the virtual environment. But I bet you didn't know that these things were there, huh? But you see, I mean, it's a pretty long scroll bar, right? So yeah, we get down towards the very end, and then we have some VS Code launch, and then here's our launch configuration. Fine, that should look familiar, right?
Yeah.
So before we do anything else, we will make a file called a gitignore file. So here's the files that we're expecting, right? There's our child file. Here's our test file. Here's our requirements file. And so if we add this, it would let us make a commit to the repository, right? So-called staged file. We'll talk about all this tomorrow, or not tomorrow, whatever, next time we meet. But you see, now we have the Git repository loaded in this program that lets you see what the files are. You see the contents over here. You'll be able to see additions and deletions from it. All very kind of clean, easy to use, right? So that was actually the last thing that I was going to have us do today. So let's go and briefly recap before we finish here. So this is what we did. We just finished installing Git with Git bash, that command line version of it here with the Unix shell, or uses bash. And so we did that. We got Git installed. We downloaded SourceTree. I guess actually the last thing that we were going to do is we were going to go ahead and look at github.com. So for now, I'll mostly just take you here. Actually, we can go look at one of my repositories, I suppose. So GitHub is it's basically where people push code, where they host their applications, their projects. You have to update your code somewhere, especially if you have multiple people developing to it. You have to store it somewhere, right? So Bitbucket, which is what you just made an account for to use SourceTree. Well, Bitbucket is basically the same thing as GitHub. It's another option. There's pros and cons between them. They're both used a lot. GitHub is probably the most prevalent one. So if you want to see the Bible teaching ministry that I have, right? So this website that I've obviously been working on for a while now. Still haven't completely launched, but hosted with the top bar and the sidebar and all this. So this is what the website looks like. Well, this is actually hosted on GitHub. So if I search for it on GitHub, you'll come to see that I'm actually hosting this on GitHub as the application platform. So, this is me, this is my account, Stephen Tamman, that's me. And so you can see, well, look, you see, remember that file that we have there, VS Code, right? Mm-hmm. Remember how we had a VS Code file that had a launch.json file in it? Well, guess what I have? Oh, look at that.
Yeah.
Great. And so I have a Python application embedded in this website. And that Python application is the one that you've heard me talk about more recently here. It's a Python application for pre-processing the content to build slides from it. And in fact, knowing what you know today, you should know more or less what that thing is, right? We're saying from this module, app module setup, right? Import a function called clean slides directory, right? That's what that's doing. And then look, a for loop and all this, you should, maybe you don't know exactly what stuff does, but you should be able to look at it and kind of know the gist of it, right? So it's the power of programming. But yeah, this is what GitHub looks like. So we'll talk about commits and branches and pull requests, and we'll talk about all that stuff once we start talking about Git. But another cool thing is it shows you what programming languages are being used. So you can see 68% of my site is HTML, right? And then I have CSS, SCSS, Python, JavaScript, right? But there you go. So this is an example of a remote code repository. In fact, another cool thing that GitHub lets you do is it lets you make a board for tracking all of the work you're doing on your project. A so-called Kanban board here, or Kanban. I'm not actually sure how you say that word. Yeah, I must have seen it written. So here's a whole bunch of in-progress stuff. Well, actually, I haven't really been tracking to work on my website with this for a while because I've had so much and it's been changing so rapidly. But if you're a good developer and you're on top of things, you can track all of your issues here in something like this. So, well, there you go. So I was just going to show GitHub. This is probably where we'll push code. So as we get things set up here, as we move forward in our programming teaching series, I will actually make a repository here, and then I'll have you pull it down, and then we'll both be working on code in the same repository that will be up here public on GitHub, right? So we can build an application together, basically, where both you and I will be able to contribute to it. More specifically, what I'll do is I'll post a bunch of practice problems to the Git repository, and then you can work on them, and then I'll post the solutions the next day so you can check yourself against them.
Okay.
All right, well, that's where we'll cut for today. So I'll go back through some of the things we've talked about real briefly before we stop here. So that was our Git preview. So what we did, we started today just mentioning anyone else in the future who uses Chrome Remote Desktop for something like this, make sure your browser extensions don't get in the way like they did for us. We talked about virtual environments, specifically setting them up in VSCode, that integrated shell there, setting up a launch configuration in VSCode. It's a JSON file. We talked about Python packages, the Python package index and the pip package manager. We talked about package dependencies and why we freeze them at the virtual environment. Right, we talked about the requirements.txt file that you build by freezing your requirements, and you can install them, or someone else can install them when they run your application. And then finally, we got some tools for Git setup to use. And we'll talk a lot more about Git and version control next time we meet, and how all of that will interface with the Python applications that we'll be writing here. But as of leaving today, you now have everything you need to develop Python applications locally in VS Code. So if you followed everything we've done the last couple times we've met, you should be able to make a new folder on your system, open it in VS Code, make a Python file, make a virtual environment, set up a launch configuration, and then build your package index, right, with the Python package manager. So pip freeze will let you build your requirements file. You do all this, and suddenly now you're all set up and you're ready to go. Right, you're ready to develop your Python applications and share them with other people. And when we next pick up, we'll be talking about how you actually get this code that you have on your local computer and you push it up to the internet in a version control repository so that other people can access it. We'll be talking about how you track your changes to it as well. So we have a bit more to do here, but we're getting closer to being fully independent, being able to code Python applications locally, and basically setting you up for how real developers in the real world work. So this is where we'll cut for now. And when we pick up, we'll be talking more about version control.